Hi and good day. Myself is Bhajan Purusan of Muthusamy and my matrix number is CD200063 and I'm from section 2. Today I'm going to present about the group report. First of all, I'm going to introduce my team member, organization chart, and Ida Arena, she's the leader and she'll be doing programming algorithms, followed by Muhammad Faris. He'll be doing the programming algorithms also, followed by Ruben Nityasulban. He'll be doing the program demonstration. And Prasant Kumar. He'll be doing the handbook criteria. And myself, I'll be doing the introduction. Introduction. Due to COVID-19 outbreaks, many of the engineering lab practices are unable to be completed by physical hands-on. Almost all lab practices need to be done through online learning. We as a team were given a chance to do a machine operation handbook together with a comprehensive C program. The handbook is aimed to assist students in understanding the lab practices or experiment, while the C program enables students to experience the lab practices or experiment during the calculation and analysis. We have developed a program to guide DR operator in using a conventional machining for selected metal parts in lathe machine. Firstly, we need to understand the conventional machine and its operation in lab, which is conventional lathe. Then propose part design that able to be done above machines. Next, propose the steps involved to machine in a raw material until you get a proposed part design. From the suggested steps, we need to develop three operations, which are facing, cutting, and threading. Assist the operator in machining. Introduction to lathe machine. Lathe machine is used in all the engineering applications and in the college workshops. Lathe machine is used to perform all the basic operations such as drilling, cutting, tapping, turning, and etc. with the assistance of various tools placed within the work environment. And there are several types of lathe machines, which are regular lathe machine, light duty lathe machine, medium duty lathe machine, heavy duty lathe machine, extra heavy duty lathe machine, and CNC machine. In given tasks, we choose three major operations, which are turning, facing, and threading. And that's all. Thank you.
Hello, my name is Prasan Kumar and I'll be presenting about chapter 2. So, chapter 2 is mainly about machine specifications, part design, and operational analysis, which also includes the calculations and formula. So, this is a lathe machine. This is a basic information for a lathe machine, which is mainly about the capacity, spindle, feet, tailstock, and the power. So this is the lathe machine specifications. So we have, for an example, we have the swing over machine bed, we have swing over cross slide, the distance between centers D806MT3, the turning length, the width of and the width of bed. So we have 17 specifications for the lathe machine. So the second part would be about the parameters and formula. So we start by the length, rotational speed, total volume, machining time, number of cuts, processing time, material efficiency, area output per day, waste generated, energy utilization, and number of starts. So we've used the LT350 machine and obtained data such as the maximum spindle speed is 600 rpm, the standard turning diameter is 190 mm, and the maximum turning length is 350 mm. In this program, the outputs are rotational speed, number of cuts, processing time, waste generated, and material efficiency. The cutting speed of a machine is affected by the type of cutting tool used and the product material. So for the waste generated, we calculate the volume of parts that machined, which are the cross section of the thread. From derivation, the formulas are waste generated P2UAR and the area of cut part, which is A will be 0.6134 P with FLTZ over 2. And the area formula derived according to the trapezoid, which is L1 equals to L minus L11 minus L12. Lastly, the material efficiency is calculated by getting the percentage of left material after the process with formula, whereby material efficiency E equals to E minus MR equals to A100. And the last one would be volume of cylinder, where V equals to pi r square H. So next would be the operational process table. We start with the first one, which is turning. The process of removing from the circumference of the workpiece is called turning operation. If the material is removed in terms of steps from the surface of workpiece, then it's called a step turning operation. Whereby taper turning operation stands for the turning operation used for producing tapered components is called a taper turning operation. And the second one would be facing. The turning operation used for reducing the length of component by removing the material from the face of the workpiece called a face turning operation. Number 3 will be thread cutting. The turning operation used for producing the threads on the surface of components is called thread cutting operation. Number 4 will be drilling. Drilling is an operation used for producing holes in the components. By number 5 will be boring, where it stands for it is an inter-turning operation used for enlarging the existing hole by some amount called boring operation. 6 will be counter boring. The boring operation used for enlarging the end of the hole is called counter boring. Countersinking. Conical enlargement of an end of the hole is called countersinking operation. Number 8 will be reaming. Reaming is like drilling operation used for removing small amount of material for sizing and finishing of the hole to get exact dimension. Number 9 will be trepanning. It is the operation producing large size holes without drilling operation. Number 10 will be spot facing, making the surface of the hole flat and the square for the proper sitting of the bolt, head or nut is called spot facing operation. Spot facing is done by an end mill cutter with a drilling machine. 11 is honing. Honing is the finishing operation used for producing an excellent surface finish on the holes. The last one would be knurling. It is a pattern of straight, crossed or angled lines on the surface of tool, which is pressed against the workpiece such that it can form an impression on the surface of workpiece. The holding of workpiece will be bettered by this operation. Thereby, we would discuss about the spindle rotation. On we will discuss the feed rate based on different amount of spindle rotation using different materials. And the materials used are mild steel, aluminum, and cast iron. And then the next table shows the spindle rotation in the producing the energy consumption. And the last one would be different materials having different amount of density with a different cost price. That's all from me. Thank you.
Hello, my name is Aidarina binti Muhammad Idris. My metric number is CD180178. Today I will be presenting about the programming algorithm, which is the flowchart of the program in the Lathe machine. So to begin, we begin the program with start, and after that we continue with the input that we have that need to be entered by the user, which is the operation and the material. The user need to choose the operation wanted in the lathe machine, which are cutting, turning, and facing. After choosing the operation wanted, the user need to choose the raw material which we have fixed it to 3 raw materials, which are mild steel, aluminium, and cast iron. After choosing the two input, the user needs to insert the spindle speed, which is limited to 500, 800, 1000, 1500, and 2000 RPM. For the raw material, we have two data that need to be entered by the user, which is the diameter of the raw material and the length of the raw material. Firstly, the user needs to insert the maximum diameter of the raw material, which we have fixed it to 300 maximum, and after that, insert the minimum diameter. After inserting the diameter, the user needs to insert the length, which the maximum length of the raw material is 350. After that, the user needs to insert the minimum length of the raw material, and after inserting the two data for the raw material, the user needs to insert the number of cuts required. As for the number of cuts required, if the user states two number of cuts, in case the user states two number of cuts, then the program will show the depth of cutting setting twice. But if the user insert only one number of cut, it will proceed to the exit loop. If yes, the program will proceed with the depth of cutting in mm for cutting, and it will show the increment operator. If else, exit loop. And after that, to calculate the processing time for a product, solid waste generated, and its productivity as well as the energy consumption, the program will be calculating following the formula we have inserted in the program, which is the turning speed is speed times pi times with the maximum diameter over 1000. After that is its removal rate, which is V turn, which is the turning speed, times with the depth and feet. And for the cutting time, L times M over L. And lastly, for the waste generated, which is W, is Q times T times P times the material density that we have in the program. So by calculating that, we will next proceed to the value and result for the processing time, solid waste generated, productivity, as well as energy consumption, and also the productivity per day. And after we have result for the previous output, the program will calculate the total energy. When the total energy is exceed more than 200, the program will calculate by referring to the tariff, which is 0.38. So for the industrial, total energy is 200 times 0.38, and industrial 2, the energy consumption minus 200 times 0.441. So the total industrial is the total of industrial 1 plus with the industrial 2. As for the total industrial, the energy consumption will be times with the 0.38, which is the tariff from the TNB. And after that, the program will end. Thank you.
I'm going to demonstrate this program that we have made. Hi, let me just run this program. Hi, my name is Ruben Alakinitya Sullivan with a matrix number CD200165. Today I'm going to show you this program that we have created from group 5. This is a lathe machine program, and there is 3 operations that that can be done in this program. So for the first step is we need to insert the operation that we want to choose. So I'm doing cutting, so this is how it goes. Press 1, enter, and next is we need to choose the type of metal, and I'm going to go with mild steel. And next is we must assign how many hours we're going to work for this machine is allowed to operate. So I'm going to put as 4 hours. And next we have to choose the spindle speed. So since this is mild steel and it's we don't need too high of spindle speed, we can choose 800 rpm. So then we have to insert the parameters of the raw material. So for the maximum diameter, I'm going to put 40 mm. Minimum diameter, I'm going to put 30. Maximum length is about, let's say, 18. And minimum length, I'm going to put at 70. And we're going to insert the number of cuts required. So for cutting, let's say I'm going to put at 4 cuts. So 4 cuts, and we need the depth of each cut. So put as 10. No, let me make it 5 millimeters. 5, 5, 5. And there you go, there it displays the result. So for the processing time for the product is about 3.75 minutes. Solid waste generated by a product is 0.003 kilograms, and the productivity per day is 64 items. In the time that we are given, which is 4 hours, we can make 64 items. Then the energy consumption for the 4 hours is about 1000 kilowatt hour. So now let's see a different process. Run. Okay, here we go. Let's try turning. This time let's take aluminum. Working hours 6. Aluminum is also a soft metal, so it doesn't require a very high spindle speed. So I'm gonna go with 500 rpm. The raw material parameters. So let's do 50, 45. Length is about 80, 75, and let's do 2 cuts. So we get let's put 5, 5. And there you go. You see the result appears, and we can see that processing time for one product is roughly 3 minutes, and the solid waste generated by one product is 0.01 kilograms, and productivity per day is 128 items. The energy consumption for 6 hours is 2400 kilowatt hour. Okay, let's see for our final process. Okay, here we have facing, so let's try facing. Okay, we're gonna do a cast iron this time. Alright, so working hours, let's put it at 8 hours. Okay, so cast iron is a pretty hard metal, so let's go with 2000 rpm. Parameters, let's go 60, and minimum 50, maximum, let's go 100, 110, Maybe let's do one cut. The depth will be 10 millimeters. So let's see. Alright, here you go, you can see the results. Processing time for product is about 0.45 minutes. Solid waste generated is 0.04 kilograms. Productivity per day 1066 items. Energy consumption for 8 hours is 3997.5 kilowatt hour. That's all from me. Thank you.
Hello, my name is Muhammad Faris bin Muhammad Ali. My matrix number is CD180219. Now I will present about the chapter 5 of our project, which is conclusion and the limitation that we face during our project. This is our conclusion. To conclude, operating conventional machines are full of challenges, such as difficult to estimate part processing time, the energy consumption, byproduct or solid waste generated, and estimate productivity per day. So my team is assigned to understand the fundamental of lathe machine. So my team have developed a handbook to guide and assist students on how to use a lathe machine and do its related operation. Okay, this is our limitation or problem that we face. Firstly, we understand that the conventional machines and its operation in our mechanical labs in UTHM campus that refers to an online info for the conventional lathe machines. Next, we propose 3 designs that are able to be done by above machines with 1 machines and 3 parts design. Then we propose the steps involved to machine a raw material until get the desired part design. Furthermore, from the suggested steps, we have completely developed 1 complete C codes, C programs to assist the operator in machining operation, which is 1 program for 1 machine part with 3 parts design. Next, in our program analysis consists the total part processing time, the energy consumption by product or solid waste generated in kilogram, and estimated productivity for 8 hours of working time. Lastly, our program shows that the detailed steps and parameters are correct. Calculation to machine raw material until you get the end product. Thank you.